The Bioconductor project exists to provide focused support for omics analyses in R. Like CRAN, which we talked about in the last video, Bioconductor also serves as a package repository, but it's different in that it is uniquely focused on bioinformatics. As of early 2020, it offered over 1,800 analysis packages, in addition to hundreds of others that provide datasets, genomic annotation resources, and recommended workflows for specific types of data. In this video, we'll go over how to get and use packages from Bioconductor. The first thing you should do to get up and running with Bioconductor is install the BioC Manager package. This actually comes from CRAN, not Bioconductor. So, following what we did in the last video, you can install it with install.packages, parentheses, BioC Manager. The BioC Manager package represents a fairly new way to install Bioconductor packages. If you've previously used a script named bioclite.r, or maybe you see that used in some old code, that method has been replaced and simplified with this new approach. As the name suggests, BioC Manager helps you manage your Bioconductor environment. Importantly, it helps you install new packages, and in the process, make sure the versions of packages you're using are compatible with each other and with your version of R. Once you have BioC Manager, you'll next want to run the install function in its default state, in other words, without any arguments. You can do this with BioC Manager : install, followed by a set of empty parentheses. This will install a basic set of Bioconductor packages. If you're asked whether to update existing packages during the installation, you'll generally want to go ahead and select A for all. You might also be asked whether to install certain packages from source. Like we talked about in the last video on CRAN, doing so sometimes requires external software on your computer, things outside of R. For example, here I entered yes, but ended up with an error message that suggests I need G-Fortran. I'd need to go outside of R and install this on my computer in order for this installation from source to work. Alternatively, I can just run the install function again, and this time choose to not install from source. In that case, the installation is more likely to go smoothly. You just might not have access to the absolute newest version of the package. At this point, you should be able to easily install any Bioconductor packages by running the BioC Manager install function again and specifying inside the parentheses, and also wrapped in double quotes, the name of the package you want. For example, here I'm installing DESeq2, which is a widely used program for differential expression analyses of transcriptomic data. Similar to installing packages from CRAN, you should only need to run the install function once for each package. Then, just like with CRAN packages, you'll use the library function to load the package in each new R session. Here, I've loaded DESeq2, and so now I have access to all of its functions as long as my current R session remains active. Finally, I should highlight that the Bioconductor project is much more than just a package repository. Importantly, it also provides lots of excellent training and support resources. I especially recommend some of the links such as courses and common workflows that you can find under the Learn section of the Bioconductor homepage at bioconductor.org. Together, CRAN and Bioconductor serve as incredibly valuable resources as they make packages available for many of the tasks you'll need to perform as you analyze your data. Not only do they make these packages available, but they also make installing and using the packages easy. In most cases, the package and any necessary dependencies can be obtained by running just a couple of simple functions. In the next video, which will be the last one in this set focused on getting started with R, we'll take a look at how to read data into and write data out of R.